Welcome everyone. I'm Dr. Himangshu Hazarika, Assistant Professor, Department of Mathematics, Tezpur College. Topic of my discussion is polar coordinates of complex numbers. These are my contents: algebraic representation, polar representation, argument, understanding the angle, examples, and references. The target audience for this presentation is undergraduate students. Now, a algebraic representation of a complex number is a plus bi, where a and b both of them are real numbers. Here, a is called the real part and bi is called the imaginary part, where I, that is iota, is I square equal to -1 or I equal to root over -1. The polar representation, as we can see in the picture, it is denoted by two parameters r and theta, where r is the distance from the origin to the point, that is root over a square plus b square, along with radius vector, and theta is tan inverse b by a, the angle made by the radius vector with the positive direction of the real axis. Now a equal to r cos theta and b equal to r sin theta. Then the polar representation of the number z equal to a plus ib is r cos theta plus I sin theta. Now let's take the example z equal to root 3 plus I. Here a equal to root 3 and b equal to 1. Then by calculation we can see that r, the distance from the origin to the point along with the radius vector, is 2 and theta equal to pi by 6. Hence the polar representation of the number is z equal to 2 cos pi by 6 plus I sin pi by 6. Now argument of the polar representation of a complex number is satisfying by the this relation, where cos theta equal to a by r, sin theta equal to b by r. Then argument of z is alpha plus 2n pi, where n belongs to Israel number. If the angle theta satisfies the inequality minus pi to pi, then theta is called principal argument and denoted by principal argument z. That means the extended argument is equal to principal argument plus 2n pi, where n belongs to Israel number. Now, if we consider two numbers where z1 equal to 1 minus I and z2 equal to -1 plus I, in this image, in the top image, it is the number z1, and in the bottom half, we have z2. By the first look, we can directly say that by the calculation, theta equal to minus pi by 4. But when we check the angles, the number z1 is in the fourth quadrant, whereas z2 is in the second quadrant. So for the z1, the angle minus pi by 4 is well fitted behind the along with the principal argument concept, but the second angle, it is not, even it is not minus pi by 4. It is, we have to adjust with it, and the angle be minus pi by 4 plus pi, that is 3 pi by 4. Now if we consider another number z equal to minus root 3 minus I, from the calculation we can say that theta equal to pi by 6, that is the red angle. But eventually the angle is not pi by 6. We have to calculate the number in the third quadrant. Hence argument of z is pi by 6 minus pi, that means minus 5 pi by 6. And the reference, these are my references. Thank you.